Hello, my name is Peyton Denny,
I'm Robin Foley.
Mervyn Nunez.
And I'll be able to blow it up.
and this is Engineering Fundamentals and Problem Solving, Chapter 4.
So the introduction to the chapter talks about design and problem solving, the approach, analysis, and solving of the problems. And there's two methods of problem solving. That's going to be the design process and TQ method. And the design process takes logical steps to solve the problem with the time and resources as restraints. The TQ method is going to be steps leading to the result that's desired with exceeding the customer's expectations. Then it has a small paragraph that explains that it's a basic guide to problem analysis, organization, and presentation. I'm going to go ahead and pass this off.
Section 4.2, problem analysis. Section 4.2 talked about analyzing the problem, and it talked about how it's important to be organized, and it talked about how analyzing leads to a better, stronger solution, looking over your problem and looking it over again until you find the best outcome for it. The process involves knowledge of mathematics, chemistry, physics, and technical subjects. Using all of these, you might have a better understanding of your problem, and you might be able to come out with the best outcome. It's also very important to have common sense, because you can look at it very many different ways, even if it doesn't involve any technical subjects. Everything must be taken into consideration, for example, price and aspect, and this is why analysis is so important.
4.3 talked a lot about the engineering method, and what the engineering method is 6 steps. And it starts with recognizing and understanding the problem. So you're going to eliminate irrelevant factors to specify the problem. Just make sure you eliminate anything that doesn't really have to do with the problem specifically. And then you're going to accumulate data and verify accuracy. All pertinent facts must be ascertained, which means make sure that all the size, the price, all those things aren't really variables, are set in stone, so to say, so that everything can be prepared. Select the appropriate theory or principle that's going to be used. So just basically use or identify constraints that could apply to the selected theories, so that you know what methods to use to go about. 4.3 continued. The last 3 steps are to make necessary assumptions, because you can't really solve everything step by step. So you're going to have a small thought process into this, discussing with your peers, and make assumptions that are necessary to complete the solution, but don't necessarily reduce accuracy. Then you're going to solve the problem. So steps 3 and 4 result in any sort of equation or math problems. Then you're going to go ahead and solve those. And then you're going to verify the results with your peers, rework the equations and calculations to verify accuracy of the results. And if the results don't seem very reasonable to you, if they seem completely out of the ballpark, then you're going to go ahead and try peer evaluation of the work, just to make sure that everything's just accurate in the experiment. I'm going to go ahead and pass this off to David Denny for problem solving.
And section 4.4 is pretty much a reiteration of section 3. Basically, we're going to go over the principles that Dylan just described, which is identify your problem, define it, explore, take action, and look back and make sure it's proper. So, this is the first. We're going to go through the 6 steps that you need to understand the problem. The first part is looking at the problem, studying it, and defining it. Oh, Smarty, can I have you read this?
Of course. If I had 60 minutes to solve a problem, I'd spend 55 minutes defining it and 5 minutes solving it.
That was said by Albert Einstein one time. Basically what he's saying is, if he's given an everyday problem in life, he's going to make sure he understands it and uses it until he tries to solve it. So your next step is to collect data and take measurements. So, like we're upstairs in the batting cage, we had to take measurements of the length of the room and the width of the room to figure out how much net we could fit in there, and also the size the net could be. It's important to double check your data and make sure that what you're trying to find is accurate and that it holds up. And you want to use exact decimals. Next is select appropriate theory. So a lot of the theories that we're going to be using for solving problems in everyday life is using physics and other scientific theories that define kind of like the physical aspect of problem solving. Next is just to research and understand why that physics theorem is that way, and say like gravity. Understand the principles of gravity and what you're going to be working against. Check for limitations and constraints. Section 4. Use common sense. You can't really illustrate this enough. Common sense is what we use every day, and it gives our audience kind of broad, use common sense. And assume that like constants will remain the same, such as gravity. Assume that it's going to work downwards the entire time, and make sure you know that. And if you come across a problem, don't hold up. Just go back and try to figure it out. I like this sign right here. Can you read that, Chris?
Yes, the sign says, when flooded, turn around, don't drown.
Turn around, don't drown. So if you come to a problem and you're problem solving, make sure to look at it, describe it, turn around and try to solve another way. And step 5, solve the problem. So your steps in 3 and 4 will most likely result in an equation that you can solve mathematically. Just go ahead and solve that, like use some simple algebra, and make sure you used exact digits and proper scientific notation. Next step is to verify and check your results. After you reach your answer, double check that your math is correct. Go back over it, use different methods of solving it. Maybe if you get the same answer, it's probably verified. And after, make sure it makes sense. Say, if an apple's falling at a rate of 9.8 meters section, which is gravity, if you measure it and get that it's falling at 1 meters per second down, squared downward, is probably not a good answer. Make sure it makes sense, and in the end, all your pieces will fit together, and you will get your answer.
Alright, standards of problem presenting. It is necessary to present the solution to some standards. It will be presented to other individuals who are technically trained but do not have the detailed knowledge of the problem that you would have. To present with clarity, the information must be communicated accurately to the audience. So you have to speak to them so they understand. Be prepared. Employers insist on careful preparation for presentations that completely document all the work involved in solving problems. And the presentation format, there are 2 formats of presentation that will be freehand and computer generated.
And this is a freehand right here. This is an example of freehand from the book. And as you can see, as everyone's talking about, you can't miss any steps, and everything has to be well organized so that the people that don't have as much knowledge as you do, which you are presenting to, they can understand and see all your work and where you are coming from, and understand that everything's going to work fine. You can see everything has to be very well organized. You have the page numbers, you have a theory, assumptions, solutions.
Thank you. Is there any questions?